Hello, everyone. My name is David Kelly. I'm a systems programmer here at the Computation Institute. So today I'm going to be talking about Faceit. It'll be a pretty quick talk, and then we'll kind of go into some demo and give you guys access so you can play around with it. Faceit is a framework to advance climate, economic, and impact investigations with information technology. So Faceit is built on top of the Galaxy platform. Galaxy was originally developed by researchers at Penn State, and the goal of it was to make it easier for biomedical researchers to collaborate, to work with a common set of tools, and to share their data between them. So there are a couple of different projects that are based on Galaxy. Globus Genomics is one that's based here at the CI. PDAX, I think, is some kind of physics or cosmology application that's based around Galaxy. Material science, and then Faceit is the earth sciences version of that. Galaxy is it's a web-based tool. It's written in Python, and it runs on Amazon EC2 resources. So if you're interested in the biological uses of it, you can check out the Use Galaxy page at usegalaxy.org. And they also have video tutorials available at vimeo.com/galaxyproject. So one of the goals in Faceit is to collaborate with different user communities to define a set of data types and tools, make tools available to those communities. So some of the work we've been doing recently is with a group called AGNIP. And we have this group of tools called RIA, which stands for Regional Integration Assessment. Basically what it is researchers out in the field go out to different farms across the world and basically give them survey data. And so once they have all the survey data, it comes in as a CSV file, and from there they can run it through different crop models and see, for example, how to increase their yield based on different variables.
But this use Faceit as central for what is it again?
So it's right now. I mean, it's mostly used for crop models, but it also. Yeah, we'll show you a little more.
That's all inbuilt. That's like standardized as Galaxy. Galaxy like a
yeah, Galaxy is sort of the underlying framework for defining how tools run and things like that, and how you define what a tool is and how different tools communicate with each other.
Is it like Galaxy's like the MATLAB, and then Faceit's going to be like user?
So Galaxy has the user interface built into it. So Galaxy is like the biology version of Faceit, or Faceit is the earth sciences version of Galaxy, basically. So there are different ways you can bring in data into Faceit. You can upload files directly from your laptop. You can transfer data from the web and FTP servers. You can also connect remote data archives to bring in climate and experiment data, for example. So this image below is an example of a workflow in Faceit. Each of those boxes represent a different invocation of a tool. And you can kind of see those noodles there sort of take the output of one tool and send it as input into another tool. And by doing that, you can sort of chain together and create a workflow. So there's also this concept of a history in Galaxy. If an item in your history is basically a file, it can either be a file that you upload directly, or it can be the output of a tool. You can visualize certain data types. You can view all the metadata, for example, latitude and longitude, quickly. And you can also convert between different formats, for example. So one of the main features here is that you can run these tools and have a set of files in your history, and then edit it as needed and share it with other collaborators. EasySim is a collection of tools within Faceit. It's sort of like the hello world of Faceit. It's just a collection of tools for running crop models, for plotting data, and for analyzing climate. There's documentation available on learnfaceit.org, and there are some video tutorials on youtube.com/RDCEP. I'm going to show you quickly now. This is the Faceit web page. On the left-hand side, you have your collection of tools. They're categorized into different groups. So, for example, the Get Data tools are all about importing data into Faceit. The EasySim tools I mentioned are for doing basic simulations, and the RIA are all the AgMap tools. On the right-hand side of the screen, you have the history, which are, I mentioned, either items you import or the output of tools. So I'm going to start with just importing some basic data. Actually, 1 second.
So how do we get to Faceit?
Yeah, I'll show you that in one moment. I just want to go through the basic demo. And then there's a web page where you have to request access. Since it's in the early beta stages, we don't want to grant it too soon. But let me just show you this 1 second. So I'm gonna go through these items here, and then it should only take a few minutes, and then we'll give you access and sort of let you try all these tasks. So the first thing is to create a Globus account and request access, upload a file into your history, rename and delete an item from your history, import a shared history, design an experiment, create a workflow, and then publish your workflow and results. Okay, so the first thing we'll do is we'll import a collection of files into Faceit. We do this by running the upload file tool. And so you can select a file locally, but in this case, I just have a couple of URLs I'm going to paste in here. And you'll see that the colors on the history items change. I don't know if you can see that in the projector or not, but when the items are gray, it's waiting to load. When it's yellow, it's in the process of running, and when it's green, it's completed. So that's actually supposed to be green. So there are a couple things you can do to interact with the data. If you click on the eye next to the item, you'll see the contents of the file if it's a text file. So in this case, we're looking at a soil definition file. And so one of the other things you can do is you can rename the file. Since these are actually called the URL, I'm just going to call this soil. The next item we uploaded is a climate file, a weather, and this is in the netcdf format. If we click on the eyeball next to that, we can see the different variables that are defined within that netcdf file. So I think in Michael's example, he was just looking at max temperature, but this one has time, precip, radiation, and all the basic components. I'm going to rename this one. I'm just going to call it climate. And this file is an experiment file. It's also a JSON file. We're just going to actually delete this. I'm just going to show you. You can remove items there. You can also have multiple histories. So these items are all in one history called unnamed history. But if you click on this gear icon up here, you can click on saved histories. Click on the down arrow next to the history you want, click switch, and you'll have the 2 files I created earlier. So now I'm going to give an example of running a workflow. This first workflow is called EasySim DSAT. DSAT is a crop model. So basically what you do is you give it 3 inputs: a climate file, a soil file, and an experiment file. And then you sort of analyze the results. You know, what
the experiment file saying what you plot.
Yeah, so I'll show you the experiment file here. So we create the experiment file with this experiment creator tool. And in there you can sort of define all of the variables. So in this case, we're looking at 10-year simulation starting in 1980. We want to use the DSAT model as the crop model. And we're going to look at maize. So I'm going to create 2 different scenarios within here. The first scenario is irrigated, and we're going to use automatic irrigation. And the second scenario is called grain-fed with no irrigation. The other 2 items here are just generic input dataset items. So you can add these to your workflow by clicking on the input dataset icon. And then you can connect these here. So I'm going to call this weather. And the third is the soil file. So unfortunately, these formats are not able to be read directly into the DSAT crop model. So we have to have this intermediate step here called the model translator that takes it from our custom formats into a format that the crop model can understand. Every crop model sort of has its own format for how to do this. So we have our custom, and then we write the translators to convert to each of the crop models. So I'm going to save this and run the workflow. And I'm going to make sure these match to right workflow. And one thing you can do here is you can save as this is running. I'll show you how to publish your history. So if you click on this gear and click on Share Publish, you can click the button to publish. Since I've already shared this one, it's available. But any user on the system can access it by clicking on Shared Data and Published Histories. So
history is really every step you take, right?
Yes.
What data set you use and what analysis you did and what your results.
Right, exactly. Right.
Come back a month later and remember.
Right.
Is that's open to anyone that's on that's working in Faceit, or?
Yeah, anyone that's in the Faceit group can access it if you select publish.
Is there a way to publish it to only a certain group of individuals, or?
There is, although we haven't figured that out yet. So we haven't had the need. Yeah.
I have a question about the workflow.
Sure.
Usually you really want in the graph user interface. You kind of you have certain menus that you pull them and then you connect them. Find what. So is there any way that you can write as a script?
Yeah, so in general, that's sort of how we create a workflow. If you just wanted to run a workflow that someone else created, you can go just select Run, and then you enter your inputs. Can you script it? Yeah, you can, although we haven't added a use case for that yet.
And part of the point of having this scripting to be able to run the analysis. So it's a little bit beside the point.
But yeah, it is convenient, I understand.
Yeah,
But
yeah.
you will have we could script it, then we will have time control.
Absolutely. There's the balance in between.
Yeah.
The always balance, right? Between
Okay, yeah, right.
fine control and customization and comfort programming and ease of use.
Right, and it depends.
For a general or a
Yeah, I'd say most of our users so far have been sort of agronomists and soil climate scientists, not computer scientists. So they might not be comfortable with it.
But so you said, can you go back again and show what an example of you have the input as a menu, right?
Mm-hmm.
And then actually it is much more than that. Input, output, model, then experimental. So these are like parameters. So how does it work? So you define a set of input files. Is that right?
Are you talking about the model translator or
Yes,
which
yeah,
part?
okay. You have a model, right?
Yes. Yeah. This is the crop model here, DSAT.
So then what is model translator?
So model translator is basically like a translator that takes it from our format into a format that DSAT understands.
So DSAT is a specific input format, and crop and climate data, weather data, soil data is not necessarily on that format. So the translator puts it in the format that a crop model needs to run and no error. So that's an example of a tool that David has written and is now the tool shed for anyone to use, right?
Okay.
So then someone else could come along and say, oh, I have a different crop model and I need it, and it takes a different kind of.
Right.
So they can, community-based, contribute a tool to the toolbox that anybody.
Okay, so you have certain template workflow. The user can come and take it and use it.
And use it
And then
or
they can modify it.
and reshare them. Yes, so it's a community platform for developing this
Yeah.
analysis type product.
Oh, that's great.
Right. Yes. Yeah. So right now we just have two crop models. We have one called DSAT and one called AppSim. But although there are plans to add more, and also to add more models beyond crop models, we want to add economic models. We want to add hydrology models and things like that. But for now, it's
All
just
these jobs run on the
yes. Right.
From your browser on the cloud, and right now we're supporting the cloud. You don't need your own to account.
Oh, you
When you talk about different
Right now,
like adding economic models, would it all be based on the same workflow where you're giving the economic model some weather input, or could it be any different type of input to the model?
It could be either, but I'd imagine it'd probably be somehow related to crop modeling somehow.
Like so, if maybe down the road we want to add economic models to this or something, would it all be based on the same workflow where you're providing the economic model some sort of weather input file, or could it be any type of
File. So right now, because our first user community is this crop modeling community, we're developing the tools to support them and using them to build the documentation on how to build your own tools.
Right.
But the framework is there's one super user, one developer per community. So say you're a computer scientist or computer study person working in CG model, in economic modeling. You go build those tools, and then your entire research group or your whole user base can use those tools for economic modeling.
And then their inputs might be GDP.
Yeah, it might be text files or GDP panel data.
Yeah,
or something. As long as they build a wrapper to make. Is that right?
Mm-hmm.
How would they? So they you go through.
Yeah, we would work with them and
tell us how to use it.
exactly. Yeah. So this is the output of our the model with the workflow we ran earlier. And if we click on the eye here, this is the raw output of the DSAT model. So you can see it's kind of a textual, almost like a CSV file, but not quite. Kind of difficult to see exactly what's going on here if you don't understand this format. So let's go ahead and run a slightly modified version of this workflow that takes that output in and plots it. So this starts out the same way. We have our experiment, our climate data, and our soil data. Run it through the model translator, run the crop model. But now we have two other steps where we take that text file and convert it to netcdf format, and then plot the netcdf file. It's almost exactly what you were doing with. Okay, and while that's running, earlier I showed you shared histories, but you can do the same thing with workflows. So you can share your workflow by clicking on the share publish button next to each workflow. And then they'll be available to all users by clicking on shared data, published workflows. So there's also this concept of data libraries, which are very similar to shared histories. The difference is that data libraries are set up by the administrators of the site. I think we have one on here. It's empty, I think. But basically, you can take files from that data library and import it into your history and work with it.
You can download any of these steps along the way.
Right.
You can download any of these.
Yep. Yeah, you just click on the, if you click on an item to expand it, and then there's a little floppy disk button. Okay, so this is the plot that was generated. So this is a 10-year window looking at harvested weight and maturity. The top line is irrigated, and the bottom line is rain-fed.